share the planet with an impressive diversity of life that can be found in many environments. Today, humans are dramatically transforming these environments through urbanization. This results in unique urban environments with greater pollution, altered temperatures, and extensive roads. Concrete jungles are a challenging place to live for most species, which brings us to a key question. Can organisms adapt to life in the city? The process of evolution by natural selection could enable organisms to adapt to cities. Natural selection is based on 3 principles. First, individuals have variation in traits, like the color of a snail's shell. Second, traits that increase survival or reproduction in the face of environmental challenges are selected, like shell colors that provide better camouflage against predators on the dark surfaces of roads. Third, selected traits are inherited by new generations through DNA, causing adaptive evolutionary change that can be observed in a person's lifetime. But how can evolution occur so quickly?
Hey everybody, as I was reading the news this week, this article just jumped out at me, and as I read through it, I found that video. I just showed you a piece of that video there. I want you to go watch the whole thing for yourself just to make sure that what I'm giving you is accurate. But the headline was pretty interesting. It says, Urban evolution, how species adapt to survive in the city. So we now know that evolution's a fact because we're actually seeing it take place in the cities. And so in my mind, I want to know what's going on, and I start reading the article. And they give us 3 examples on how we know evolution is happening. So take a look. They say that brown rats in New York City are evolving smaller rows of teeth, maybe I should say. Tiny fish across the eastern US have adapted to thrive in polluted urban waters, and white clover in downtown Toronto is less likely than clover in surrounding rural areas to produce a cyanide that deters herbivores. So we have 3 examples there, and as we watched that first clip, there were some interesting things that popped out. So let's take a look, and here's the points that stood out to me. They gave us 3 principles for evolution. Number 1, individuals have variations in traits, and what we saw was the picture of the snails with different colored shells, and boy, that's a fact. I can't argue with that. The second principle, they said, was traits that increase survival or reproduction in the face of environmental challenges are selected. So we saw the different colored shells on the snails, and the bird could see the light colored shells, and so the bird ate the light colored shells, and that means that they disappeared and that we got brown colored shells. And then the third principle, very simple, makes sense, was selected traits are inherited by new generations through DNA. And that's pretty simple. All that's showing us is that if you have snails with brown shells, they have offspring with brown shells. So let's keep going though, because I want to expound on one of the examples that they used on proving evolution, and that's the very last one down there that says, white clover in downtown Toronto is less likely than clover in surrounding rural areas to produce a cyanide that deters herbivores. Let's take a listen to what they have to say about that and see if we can understand how that can make a worm turn into us. Take a look.
Meet Trifolium repens, or white clover, a plant species that is extremely widespread and grows in both non-urban and urban areas, making it an ideal model organism to study adaptation to cities on a global scale. While they may all look the same, there is variation from plant to plant in that only some white clovers can deter herbivores using a poisonous chemical called hydrogen cyanide. The ability to produce hydrogen cyanide is coded in the plant's DNA by 2 genes with a simple and easy-to-study pattern of inheritance. Scientists from the University of Toronto, Mississauga, led a global collaborative study with researchers from around the world. In total, they sampled white clover populations in 160 different cities. In almost half of these cities, clover populations evolved differently along urban and rural gradients, such that populations in urban areas typically evolved to produce less hydrogen cyanide, and populations in rural areas evolved to produce more hydrogen cyanide.
So what did we learn about clover? First of all, some clover has cyanide, which means that if the snail or a rabbit or something like that eats it, it's not going to be good. And the second thing we learned was that some clover doesn't have cyanide, so the snail and the rabbit could eat that. And the other thing that we learned is that most clover in the city doesn't have cyanide. So there you go. You got clover with cyanide, you got clover without cyanide, and the clover in the cities doesn't have cyanide, but the clover out in the country has cyanide. So how does this explain evolution? How does this explain a worm growing legs? Keep watching, we'll learn.
When land becomes developed and urbanized, the abundance of herbivores tends to drop, making hydrogen cyanide less advantageous for survival and reproduction. After all, producing this poisonous chemical compound costs a lot of energy. Energy that could instead be used for producing flowers and seeds. With each passing generation, clovers that produce hydrogen cyanide become more rare, while clovers without this ability increase. And because the effects of cities get increasingly strong towards the urban center, this helped lead to the difference in clover evolution along urban and rural gradients occurring repeatedly around the world.
Okay, what did we learn here? Well, first thing that we learned is that more animals in the country are eating plants. And the second thing that we learned was animals in the city, there's not as many of them, so they're not eating as many of the plants. So therefore, what that does is it allows the plant to use less energy to produce the cyanide, because it takes more energy to produce the cyanide. So it can use that energy to survive in that fallen environment, that city environment. How does that show that a worm grew legs to crawl out on the land to become an amphibian? I mean, what did you start with? Well, you started with plants that were able to produce cyanide and plants that couldn't produce cyanide. What did you end up with? Plants that can produce cyanide and plants that can't produce cyanide. I mean, you just changed the population numbers. Now, one example that they used in this article is like the best evidence for evolution in the city is the peppered moths. Probably the best example of urban evolution is the English peppered moth, whose coloration darkened in the 19th century in response to coal pollution. So the story goes like this. You started off with dark-colored moths and light-colored moths. So you had dark and light-colored moths. But what happened is that before the coal plants came along, you had the trees that these moths would land on, and the light-colored moths would blend in, okay? So they would blend in because it was a light-colored tree. But then what would happen is that the dark-colored moths stood out, so the birds could see the dark-colored moths and they would eat them. So you had a shift in population. You had a lot of light-colored moths and not so many dark-colored moths. But then the coal mines came along, made everything sooty and dark, and so the tree trunks changed colors, and what happened was, well, now the dark colors blended in, and the light-colored moths, well, they stood out. So now you had the birds, and they were eating the light-colored moths, so now you had a shift in population again. So what does that prove, if anything? You have light-colored moths and you have dark-colored moths. But one thing that you might not know is that the moths don't even land on the trunks of the trees. I mean, these pictures that we see in the textbooks over and over again of the light-colored moths and the dark-colored moths and different colored trunks and one standing out and the other not standing out, that's not true. As a matter of fact, in 25 years of research, one gentleman, Mr. Clark, who studied these things in depth, 25 years, he saw one moth land on the trunk of a tree. That's not where they land. They land up on the branches, on the twigs, and underneath the leaves. So all of these pictures, which you don't realize, all of these pictures that we see in the textbooks being used to prove evolution because you got different colored moths evolving one from another, they didn't evolve. You started with light-colored moths and dark-colored moths, and all you had was a shift in population, and all those pictures you see of them on the tree trunks, they're dead moths that they glued on. So guys, before you sell out for what this world is throwing at you, be very careful, because the evidence doesn't support that a worm grew legs to crawl out of the land, to become an amphibian, to turn into a rat, to turn into any other mammal, including us. By the way, if you download our app, look for Reasons for Hope, you go to your app store, there is so much video on there that's going to help you with all these types of questions and issues. I mean, hours of video that are on there. And also, we have a new book out. Let me show you a commercial for it.
Last several years, the R4H team got teens to jot down questions about the Bible. We wrote a book about it. Did Jesus commit suicide? And 27 other questions teens are asking about the Bible that adults want to know too. Yeah, long title, but a great book. Get it today at r4h.com.
By the way, there's just a few of the questions listed in that commercial here. Let me read a couple more to you because it's a lot. How do you know something is true with absolute certainty if you haven't witnessed it? Did God use evolution to create the world? Were cavemen and cavewomen ancestors to humans today? Why does a good God allow bad things to happen? These are all questions that the younger generation asked us. We compiled them and now we're answering them. So please take a look at the book. I hope that it'll encourage you. But the bottom line is, just because you got different colored snails and moths, and you have changes in populations in those snails and moths, that does not mean that one thing can turn into another. And this is where the deception begins, because I absolutely agree that speciation takes place and that you've got some animals that they will survive in certain environments based on traits that they already had. There's no new genetic information being added to these things. It's just a redistribution of existing information. So the next time you see that evolution is a fact, make sure what they're talking about. If they're talking about speciation, yes, we agree with it. But if they're talking about something new being added to turn a worm into something that grew legs to crawl out of the land, that's a totally different story. There's no evidence for it, and you don't need to be worried about it. Don't be deceived. Thank you. Stay bold.